Good morning, everybody. I hope you're doing all right and enjoying your time away from school. Um, so we're just going to continue on with our exponentials unit. Today we're going to talk about some financial aspects. So these are going to be a lot of dealing with money in terms of interest and things like that. So this is kind of your main formula that you're going to want. I'm sorry that you can't actually see all of the pieces of information. I don't know what exactly happened there. But this is what we call the compound interest formula. So the final amount, you can go ahead and edit this if you want. So the final amount is equal to the principal. The principal is your starting amount. And then it times this kind of fancy formula. And um, when I say this fancy formula, what this really is 1 plus the rate times the time. And that's actually really similar to the formula that you were working on last week with exponential growth. Growth, it was the principal times 1 plus the rate to the power of time. And the only new thing being added here is this divide by n and times by n. So this time is still the same. The rate is still the same. You still have to put it as a decimal. The only new thing is this n. And so before, what was happening is we were calculating our exponential at just kind of this like compounding rate of once. Like it happened one time for every time. So like if we were looking at years, it happened once per year. If we were looking at like days, it happened once per day. And so what we're going to look at is what happens when it compounds more often than that. So this is kind of like your compounding amount, how many times it compounds. So for example, you might be looking for 7 years. What's the amount after 7 years? But it calculates the rate every month. And so because those don't match up directly, we have kind of this new addition to this growth formula. This formula will always be plus because we're always calculating the interest. So the amount is always going up here. All right, so what I have is I kind of have like one mega example. So we're going to do this same situation, but we're going to calculate it for all this different compounding time. And then I just kind of talk about which one's the best, and then hopefully that'll be good, and you can go ahead and start on your assignment. All right, so congratulations, you just won $1,000 from a local company. However, they require that you invest your money until you're 25. So we're going to assume that you're currently 16 because I know everybody's probably a different age. So we're going to assume you're currently 16. Before you invest your money, let's discuss your options. You find an investment opportunity that will give you a 3% return on your money. So all of this information is going to stay the same for this entire problem. And what we're going to change is we're going to change the n, the how many times does it compound. So we're going to try to do it, or not try, we are going to do it where it compounds annually, semi-annually, quarterly, monthly, weekly, daily, and then we're going to look at this other one called continuously. So for every single one of these problems, your principal is the same. Your starting amount is $1,000 for every single one. The rate that we're going to look at is 3%, so that would be 0.03, and that is also the same for every single one. And then the time, how long, assume you're currently 16, you have to invest till you're 25. So it'd be right 17, 18, 19, 20, 21, 22, 23, 24, 25. So that's 9 years. So we're going to invest for 9 years. And so what we're going to do is we're going to calculate, we're going to write out the formula, the differences, small differences. We're going to calculate them and figure out how much money we have made off that account. So let's start with annually. Annually is once per year. So if we're going to calculate something annually, n will be equal to 1. It just happens once per year. So our formula would be the final amount, A, is equal to the initial amount, 1,000, 1 plus the rate, 0.03, over how many times it's going to compound. In this case, it'll compound just once, to the power of 1 times the time, 1 times 9. And when you calculate this, it will give you your account total. So the only new thing kind of this addition is the divide by 1 here and the times by 1 in the exponent. So grab a calculator either on your phone, you're definitely going to need it, or you can use that one that I posted last week with Desmos, and you're just going to calculate this value. So 1,000 parentheses 1 plus 0.03 divided by 1, close your parentheses, and this will be to the power of 1 times 9. So this value is 1,304, and we're going to round to 2 decimal points because it's money, so 0.77. And this is $1,304.77. So what was the total amount that we made? Well, if we started with 1,000 and we ended up with just over 1,300, we made $304.77 in interest in those 9 years. So just by putting our money in there at that specific rate, that is our total amount that we made. All right, we're going to take a look and see what happens when we compound semi-annually. Semi-annually is twice per year, so that means that n is going to change to 2. So everything about the formula is the same. Your principal is the same. You're still starting with 1,000. It is always 1 plus the rate, which is still 3%, but this time, instead of them doing the calculation once per year, they're going to do it twice per year. So we're going to divide it by 2, and then times in the power, you're going to have 2 times 9 in your power, and you're going to calculate this and see what we get. All right, if you're using this calculator, you can actually just click and go back and change the 2 and change that one to a 2. That will save you some time there. So a little bit of a shortcut so you don't have to type it in again. $1,307.34. So how much money did we make here? Well, we made $307.34. So by compounding 2 times per year versus 1 time per year, we've actually increased the amount of money that we made by about $3. Not a huge jump, but definitely more money for sure. All right, quarterly, that's going to be 4 times a year. And so same exact formula, but this time it's going to be 0.03 divided by 4 to the power of 4 times 9. And so you can go back, just change the 2's to a 4, change both of them to a 4, and we're at 1,308.6, and this one rounds up to a 5. So once again, we have increased the amount of money in our account from before, just slightly more, 308.65. And so I bet you can see the trend that's going to happen. The more often that you compound, monthly, weekly, daily, the more often that happens, the more money that you are going to make. It's not necessarily a crazy amount of money. Granted, we only put $1,000 in this account. The more money that you start with in the account, the bigger the gaps you will see. So the more money you'll see that you make on the other side. All right, monthly is 12. Weekly, there are 52 weeks in a year, and daily is 365. I know we could get into this whole like leap year, blah, blah, blah thing, right? We just roll with 365. Don't worry about like 365.25 or anything like that. Just 365, and it will get you a very, very, very good estimate of what that number is. So I suggest you pause the video and see if you can do these 3 calculations on your own. See what you come up with. When you're done, go ahead and hit play, and I will do them out. You can just make sure you have the right answers. All right, so monthly would be 1,000 1 plus 0.03 over 12 to the 12 times 9. So back to the handy calculator. We're going to change that to 12 and change that one to 12 as well. 1,309.52. So you've made 52. So it did go up just a little bit. Our next one weekly, that will be 52 instead of 12. And so 1,001 plus 0.03 over 52 to the power of 52 times 9. 0.86. That's kind of frustrating that difference there, right? It's like, 24 cents? 34 cents? Sorry, 34-cent difference. Compounding monthly versus compounding yearly. So as you compound more often, you do see an increase in the amount of money. Not necessarily a huge increase, but definitely an increase. All right, and then the last one was 365. I have 1309.95. That one will round to a 95. So bringing us to 309.95. So once again, it did go up. This time, it only went up by 9 cents? So you can see the small differences that are going to happen as you compound more often. So it's still compounding each problem. We're compounding for a total length of time for 9 years. But instead of doing the calculation once per those 9 years, so it happens 9 times, this one would do it twice per those 9 years. So it would calculate this amount 18 times, so on and so forth. Even if you calculate it a bunch of times, you're going to see relatively kind of the same values here. Now, how do you get bigger differences? Well, you have a bigger principal, bigger starting amount. So more than $1,000. If we were to change this to $10,000, we would see a bigger change here in the general amount. Instead of like 9 cents and 34 cents, you would see a lot bigger values. Also, if the principal was a little bit higher, 3%, or not principal, sorry, your rate was higher, 3% is not actually a very high number in terms of percents. Now, in terms of investments, kind of depending on what you're investing in, at 3%, you just kind of have to, I don't know, play the investing opportunities. So, you might be around 3%, you might be higher, you might be lower, depending on what kind of account you're looking at. So those rates are also important in this context as well. So the bigger the rate, obviously the bigger return on your investment. The more money you put in, obviously you're going to make more money because you put in more money. And so we have this one final investment rate, and this is what we call continuously. And so to compound continuously, continuous is like it's always compounding. So it's going to actually compound more than 365. There's no specific end value. It's just continuously compounding. Like it compounds. It's just they're doing the calculation all the time, right? And so there's actually a different formula for this. It's A equals, so the final amount, just like before, your principal. And then instead of 1 plus or 1 minus, it's this value E to the power of your rate times your time. People refer to it as the PERT formula, PE to the RT. A is the final amount, P is the principal, R is the rate in a decimal just like before, T is the time just like before. This new thing that you have is this E value. And E value is kind of like pi. So pi is just a number, right? So if you were to hit here, I can show you on my calculator. you were to hit pi on the calculator, it would tell you it's 3.14159. You're probably really familiar with that, right? And that number comes out when you're talking about circles. So anything circle related is when you're going to see this pi value appear. E, if you're using this calculator, is actually right next to it. And so E is similar to pi in terms of is just a value. E is equal to 2.718, and it keeps going forever, and it never stops, and it never repeats, although it looks like it kind of has a repeating pattern going on right here. It doesn't. But E is kind of like the pi of the exponentials, all right? So pi comes out when you're talking about circles. Well, E comes out when you investigate exponentials in a lot more detail. And so that's the continuous compounding. Anytime it's continuous, you have this E value that pops out. And so it's going to be kind of this new formula. Just know that E is a number. It's not a variable like pi. Pi is a number, not a variable. And then you can just go ahead and do your calculation. So your amount would be 1,000, and then this will be E to the power of R times T. And your rate is 0.03 times your time, 9. All right, so calculating this, we have 1,000. And then there's actually two E's on this version. There's an E down here and an E to the X. Since I'm going to put in a power, I'm just going to hit the E to the X because there's already going to be a power put in for me. Save me some time. 0.03 times 9. And we have 1,309.96. And so guess what? It's actually even better than the one before, just by a penny in this case. But it is in fact better. And so you'd make 309.96 in interest. So which option is the best for your investment? Since you're investing them all at the same rate and the same time, the more often it compounds, the more money you will have in the account. And so as you're working through these, just kind of remember your different end values, because depending on what keyword they give you will depend on what end value you use. If they use the word continuously in any context, they say continuously in any part of the problem, that is going to be your hint that you're going to shift to this other formula that has a base of E, all right? So if it says compounds and it gives some kind of time frame, use the time frame. But if it says continuously in any capacity, you're going to jump to this other formula. All right, so your assignment is we have 12 questions. The first 9 are going to be very similar to what you see here, except for instead of calculating like all of them for just one situation, they're kind of all different situations. And then when you get to 10, 11, and 12, this one's going to be interesting. It wants you to figure out when you can reach this amount of money. And so when it says when, we're asking you to actually calculate the time here. What's the time? And so if you think about any of your formulas, the time is going to be in the exponent. And so my recommendation to you is, because you probably don't know exactly the algebra to solve because nobody's taught you that yet, but it doesn't mean that you can't figure out a solution. So a good option to solve these problems is to see if you can guess and check what the time frame is. All right, so you're going to put in your equation and try different time amounts so you can figure out how long it's going to take. So for example, this first one, you invest $1,000 at a fixed rate of 7% compounded monthly. Monthly is 12. When will your account reach $10,000? So we want to know, when does the equation equal $10,000? So you're going to set up your equation. And you're going to plug in values of t. So you're going to pick time. You maybe pick 10, maybe pick 100, I don't know, wherever you want to start at. Plug in time values and see if you can figure out how long it will take in this situation for 1,000 to reach 10,000, all right? So those ones slightly different. When you get into pre-cal, we will actually learn the math and how to solve this algebraically, so you don't have to guess and check. But for now, those are perfectly good problems that you can still solve using this math skill of guessing and checking. So Those ones are still on the table as well. All right. That is all I have for you. So your assignment is just 1 through 12. And when you're done, I'll go ahead. Um, when you're done, just hold on to it until I see you all on either Monday or Tuesday. I'm hoping that I see you either Monday or Tuesday. So that is kind of the game plan. Please let me know via email, or you can post on Google Classroom if you have any questions, and what I can do to help. All right. I hope you have a good day.